So 3, 4 was solving log equations and exponential equations. So remember there was a couple of different kinds. If there was an e involved, we would ln. If it was that we could change the base on both sides of the equal sign, we would change it to be the same and then use the one-to-one property. If it was ln or log, we would change it to log base e or log base 10 and get it into exponential. And then something like 3 here, we have to condense first and then get it into the one-to-one property. So for 2, as soon as you see that e, you should be knowing that you're going to eventually have to take the ln of both sides, but I've got to work so that the e is by itself first. So I'm going to add the 3 to both sides. And I get 2 e to the x equals 13. Divide by 2, and I get e to the x equals 13 over 2. And then ln both sides of your equation. Ln of e to the x becomes x, and then the ln of 13 over 2 is 1.8718, which is 1.872. So we're going to round these to 3 decimal places. The only thing you're not rounding to 3 decimal places would be your interest problems, okay? Money you're going to round to 2 decimal places because that's how we talk about money. Questions on that one? All right, 2 is log. There's only one log on one side of the equation, so I want to convert this into exponential notation and then solve it. So log itself is really log base what? 10. So this becomes log base 10 of 4x equals 2, and then 10 to the second would equal 4x. 100 would equal 4x. X would equal 25. And the ones that have the log in the initial equations are the ones you have to check. So if I take and plug that 25 back in, I end up trying to find the log of 4 times 25, which is bigger than 0. So I know that I'm fine. I can actually work it out and know that that's 2 to know that my answer's right. But the first thing you have to do is check to make sure you can even find that. So it has to be a positive number. It can't be 0 and it can't be negative. And this one works. Questions on that one? All right, 3, I've got 2 logs on one side of my equation, so the first thing I have to do is condense them down into one log. If it's addition, when I condense, what do? Multiply. So this becomes log base 3 of 5 times x plus 2 equals log base 3 of x plus 6. And then the one-to-one property says if there's the same log on either side of the equal sign, I can take what is next to it and set it equal to each other. So 5x plus 10 would equal x plus 6, and then subtract the x. So I get 4x, subtract the 10, I get negative 4, divide, and I get negative 1. The initial question had a log in it, which means I have to check this answer. There's nothing to plug in here. When I plug negative 1 in here, I get negative 1 plus 2, which is 1. I can find a log of 1. And if I plug negative 1 in here, negative 1 plus 6 is 5, and I can find the log of 5. So even though my answer is negative, once I plug it back in, that negative becomes a positive number, and so that's fine to keep.
If we were to get the one that's extraneous and it's the only one, it would be no solution.
Correct. So if I only have one answer, or I have 2, but they're both extraneous, then you just write no solution. Questions on the warm-up? Okay. All right, so your quiz covered the first 2 sections that are on here. Pretty much everything that's on your quiz will be on your test. I did throw in a word problem from the 3.1 section. So something with an exponential function in which you have to plug values in and figure it out. There's 2 in your review, okay, to kind of give you a heads up of what it might be like. But just know how to apply an exponential function, that's all. You should be able to plug a value in. So you're in 3.1, you're graphing your exponential functions. This would be done without a calculator. The word problem would be done with the calculator. The interest problems with the calculator. So the non-calculator part would be something like the graph from 3.1, the graph from 3.2, and then some of the simplifying logs that can be done without a calculator. Any questions on your quiz for the exponential graph? Oh, yeah. So for your graph of your exponential function, let's just say, for the sake of time, we'll keep it basic. If it was x x to the 3 to the x like that. I would plug in my values, -1, 0, and 1. It will ask you for domain and range. It will ask you for, in a exponential function, you have a vertical asymptote, a horizontal asymptote, and then it will ask you for your y-intercept. So just like the quiz, make sure you be able to answer all those questions.
The ones you highlighted are the ones that...
No calculator, exactly. And then your interest problems, make sure you know your formulas. So A equals P1 plus R over N to the NT. A couple of you messed that up. Not very many, though. That's the good news. And then PERT, most of you got right. Be careful on your order here. So common mistakes made on the interest problems were people doing this first and then raising it to the NT. And you guys were getting like overflow error. It's trying to raise a number like 10,000 to the power of, I don't even know those numbers, like 192, which is an insane number, right? The only thing you're raising to that exponent is what's inside the parentheses. So you get like a 1 point something, and you're raising that to the power first and then multiplying it times your principal balance. So be careful on the order that you type that in. If you're graphing calculator and you put the parentheses in right, it will do it correctly. You just got to be careful. And then the same thing with your PERT. The E is the only thing being raised to the RT. And then you would take that and multiply it times the principal balance. So make sure you do the exponent first. And make sure you know those formulas. For 3-2, it's, simplifying simple logs. Those were on your quiz as well. And then the graphing of the logs. So you say you're graphing something like f of x equals log base 3 of x plus 1, okay? Something like that, where you have to get it into exponential. First plug in the y. Get it into exponential notation. So 3 to the y equals x plus 1. 3 to the y minus 1 would equal x. And then do your t-chart. But when you plug in for logs, you plug into the y coordinates. And then make sure you can answer questions like domain, range. This time it's a y-intercept. An x-intercept. And a vertical asymptote. For your exponential, it's domain, it's range, it's a y-intercept, and a horizontal asymptote. So again, all of that's on the quiz review and your quiz, and I posted a test review. Most of the questions are odd, so you can check your answers as you're going. I'm going to collect that at the end of class tomorrow, so you can choose to do it at home in peace tonight if you'd prefer it, or if you have super exciting trick-or-treating plans and you want to do it in class tomorrow, that's fine too. Just make sure that you have enough time to do it so you don't turn in an incomplete assignment. Questions on any of those? Anybody need me to do one of the questions from the quiz for the graphing? Anybody not know why they got something wrong? All right. Three was the properties of logs. So for these, you're condensing and expanding. So if I had like log base 3 of a times b, then it's the same thing as log base 3 of a plus log base 3 of b. And you can get it one way or the other. So either you're condensing, or you're taking the one on the left and expanding it, or you're taking the one on the right and you're condensing it. Okay, directions will say what to do. Then you had the quotient property. So like log base 3 of a over b. Division becomes subtraction, or subtraction becomes division. Again, same thing. You can go to the right to the left or the left to the right. And then we had the power property. So if I had something like log base 3 of a to the 4th, it would be written as 4 log base 3 of a. And if you had 4 log base 3 of a, it can be written as log base 3 of a to the 4th. Okay, also in 3.3 was the change of base formula. So directions are going to say rewrite as the ratio of A common logs and B natural logs and then find the value. So if I said something like log base 9 of 7, the common logs would be log of 7 over log of 9. And the natural logs would be ln of 7 over ln of 9. So even if your graphing calculator allows you to change the base, make sure you know how to write it as the ratio because it's going to ask for it. And then also make sure you know how to get from from just writing the ratio to getting your answer, which should be 0.8856, which is 6. Be careful with your rounding. I'm going to be picky. So you need to know how to do all those parts. Remember the larger number, but not by value, but by physical size, when you write it, is the one that goes in the top. So this would be log of 7 over log of 9. That little 9 is your base. Think base bottom. Okay, and then 3.4 was kind of how we started the day. So it's solving logs and exponential equations. The first kind where we were changing the base so that you can use the one-to-one property. Or if the log is the same on either side, you can use the one-to-one property. So both of these are kind of examples of that. So if I had 1/3 equals 27x plus 2, I would change them so that they have the same base. So the 3 would go to the top. That would be 3 to the negative 1. And 27 is 3 to the 3rd raised to the x plus 2. Once those bases are the same, I would set my exponents equal to each other. So negative 1 would equal 3x plus 6. Subtract the 6 and divide by 3. And I would get x equals negative 7/3. And then log base 3 of x plus 6 equals log base 3 of 2x. This is again the one-to-one property because both sides have the same base. So I would just set the x plus 6 equal to the 2x. Subtract the x and I get x is 6. These are the ones you have to check. So if you get your test and you want to put a little asterisk or star next to every single one that starts with a log so you remember to check your answers, do it. It's the logs and the ln's, anything that starts that way. So this, I'm going to have to take this and plug it back into here. 6 plus 6 is 12. I can find log base 3 of 12. And then plug it in here and I get 12 as well. As long as those numbers are positive numbers, you can find it.
So you're just checking to see if it's positive?
Correct. Once you simplify what's in the parentheses. So if that was like x minus 7, 6 doesn't work because 6 minus 7 will give me a negative 1 and I couldn't find it. Christian.
Do you have to show the word for like...
The checking? No, just make sure you do it.
All right.
Yep, because if it's one you don't check and you count it, it's wrong. So you gotta be careful.
Oh, wait, can you go back?
Mm-hmm. And then we talked about exponential equations with e, and these are the ones you want to work to get e by themselves, and then you're going to ln on both sides of the equation. So I did just something simple to be quick, but e to the x minus 4 equals 10. I would want to move the 4 to the other side so that it becomes e to the x equals 14, and then I get the e by itself, so I ln both sides of these equations. This would cancel and I get x equals ln of 14, which is 2.639. And then we had logs or ln's. If there's just one single log or one single ln, you want to change it into exponential notation and then solve it. And again, these start off as logs or ln's, which means at the end you better check. So if I had log of x plus 2 equals 3, the base on that log is what? So this would be log base 10 of x plus 2 equals 3. 10 picks up the 3. I get 10 to the third equals x plus 2. 1,000 equals x plus 2. And 998 would equal x. Take it, plug it back in, make sure it's positive next to that log. It is, so I keep that answer. And then if it was ln, that's really log base e of x plus 2 equals 3. The e comes over, picks up the 3. And I would do e to the third minus 2. Don't round before you can. So like I would not do e to the 3 and then round that answer and then subtract 2. You want to make it e to the 3 in your calculator, keep it, and then subtract 2. So this would be 18.085, which is 0.855 or 0.86. And then again, check it. Plug it in. You've got a positive number there, so I know I can keep it.
So you check it whenever there's log?
Yep,
ln.
or ln.
But how about e?
Doesn't matter. You can raise e to any power.
Okay.
Yeah. You could check it to see if it's right, but you don't have to check it to see if there's an extraneous root. There's no such thing as an extraneous root with an e to a power.
Okay.
This one was your factoring, so I factor this out. I'd get e to the x, factors of negative 30 that sum to negative 1, negative 6, positive 5. Set them each equal to 0. And then ln both sides. You cannot find the natural log of a negative, so this one's going to cancel out. And ln of 6 is 1.792. Times we're condensing to either solve or to use the one-to-one. So on the left-hand side, that's addition. When I condense it, it becomes multiplication. So this would be log of base 3 of 4x equals log base 3 of 5x plus 3. Once the bases are the same, I can set these equal to each other. So 4x would equal 5x plus 3, negative x would equal 3, and x would equal negative 3. This time, when I plug it back in to either here or here, I get a negative, which means I would rule this one out, get no solution. And then on the right, this would be log base 3 of x over 4, because it's subtraction, equals 2. I only have one log here, which means get it into exponential notation. So 3 to the 2 equals x over 4. 9 equals x over 4. And x equals 36. Check it, and it works. So I keep it. The last one we already went over. Hold on.